Okay, so we are starting out now with 7.1. To start off, exponents represent repeated multiplication. The number that is being multiplied is called the base. The number of times that the base is being multiplied is called the exponent. In order to evaluate an exponent, write the product in expanded form and then simplify. So, for example, number 1. In words, this would be 4 to the 5th power. As a product, this would be written out as 4 times 4 times 4 times 4 times 4. And then go ahead and do the same for 2, 3, and 4. This is something that we went over at the beginning of the year. Okay, so now they're asking us to do the opposite. Write each expression using exponents. So, for looking at number 1, our base is going to end up being 2 because that is what is being multiplied. And then we count to see how many 2's there are. 1, 2, 3, 4, 5, 6, 7. So this would be 2 to the 7th. A little bit more difficult on number 2, we have 6 times 6, which gives us 6 squared. And then we also have 1, 2, 3, 4, 5 to the 4th. Let's go ahead and move on down to rational exponents and radicals. So sometimes fractional exponents are used to represent power of numbers or variables. The numerator of the fraction m represents the power, the denominator n represents the root. The exponent of the denominator must always be positive. So basically we are going to be talking about going from an exponent to a radical or a radical back to an exponent. It is a very simple formula. It is this exact formula that is right here. So they go through and they give you 3 different examples. So to start off, the first example that they give you is x to the 1/2. So x is my a, my m is 1, and my n is 2. Now they already gave you the answer, but I'm going to go ahead and do it again. So looking at this, we draw our radical. We put our a inside. We put our a to the m power, which was this top number, so a to the 1. And then where the n is, in this little crevice, we put the 2. However, 2 things that allow us to simplify this even more is that we know that if there's a 2 in here, it's the same thing as the square root, and anything to the 1 power is just itself. And I actually messed up on this one. This should be the square root of x because our a in this case is x. So now let's go ahead and look at, we're going to skip letter B and we're going to look at letter C. So letter C says x to the 2/3. So we identify our a, we identify our m, and we identify our n. And then we take those things. We draw our radical. We know our a goes inside. Well, our a is going to be our x. We know our m is our exponent for our a, so that is going to be 2. And we know that our n is 3, and that is what goes in that crevice. If I were to read this as words, this would say the cubed root of x squared. So now we have more practice problems down here. I'm going to go through one of each of these. So starting out with letter A, we have x to the 2/5. X is our a, 2 is our m, 5 is our n. So then we write our radical. Our a goes inside. Our a is going to be x. Our m is our exponent for our a, so that is going to be 2. And then our denominator is going to be what goes inside of our root. This is saying the 5th root of x squared. Last one we're going to go through is right here. Instead of going from an exponent to a radical, we are going to be going from a radical to an exponent. So we still need to label all of our pieces. Our z is our a, our 2 is our m, and our 3 is our n. So then we take those things and we rewrite it in this form. So we have our a, which is going to be z. We have our, then to the m over n. Our m is 2 over our n is 3. Those are two really straightforward examples. We will be doing B and D in class tomorrow. You may go ahead and flip your page. We are going to learn one rule when it comes to exponents. So when you have a bunch of exponents, let's say x to the 5th times x to the 6th times x to the 3rd, there are rules that you must follow in order to simplify them. So we are going to go through the first of those rules today. The first rule is called the product rule. And it is when you are multiplying powers with the same base. So for example, x to the 6th times x to the 3rd. When you multiply powers with the same base, you add the exponents. So I keep the base the same, but I add 6 plus 3 to get x to the 9th. So anytime you are multiplying bases that are the same, that have exponents, you are going to add the exponents to get to your final answer. Another example would be x to the 3rd times x squared, which is x to the 3 plus 2, which is x to the 5th. There may be times when you are going to have a coefficient in front. Let's say 5x squared times 3x to the 5th. In this case, you are going to take care of the coefficients like you always would. What do you do with coefficients when there's a multiplication sign in between them? You multiply them. What is 5 times 3? It is 15. And then we have x squared and x to the 5th, which we know if we add those two exponents together, because it's separated by multiplication, it's going to be x to the 7th. One more example that we need to go through is what happens if there are multiple variables, such as 3x squared y times 2x to the 3rd y squared. In this case, you're going to follow the same steps. You take your 3 times your 2, and you get 6. And then you add the exponents that have the same base. In this case, we have x to the 2 and 3, where we have to add these two, and we get 5. And you get y. When y does not have a number, or when a base does not have an exponent, we know automatically it is always going to be 1. So we have y to the 1 times y squared, which gives us y to the 3rd. You can only combine bases and their exponents when they have the same base, such as the x's and the y's. I cannot add y to the 1st and x to the 3rd. It does not work that way.